We're going to get started on the notes for volumes of solids. This is part 2 in our solids unit. I'm using a new microphone, so hopefully you'll be able to hear me okay. Let's get started though. Again, we're going to be using the formula sheet. This is the part we're going to use. Unfortunately, the last video that I made, I used the incorrect formula sheet. I used an older version. This is the one that we want to use though. This is the one from the most recent formula sheet and the one that you'll receive on your test, your SOL. First off, let's find out what the volume of a sphere is. So hopefully you all know this shape right here is a sphere. So the volume is going to be 4/3 pi r cubed. So again, just like with our surface area, we need to figure out what all of the variables are. So we're asked to find the volume of this sphere. We know that the radius is going to be half of 32, so it's going to be 16. And then all we do is plug it in. So on our calculator, we're going to type in 4/3 times 16 to the third. So that's going to be, let's turn into a fraction. It's going to be 1,634 over 3 pi, which is about equal to, I forgot an 8, which is about equal to 17,157. Of course, we need our units, so it's going to be meters cubed. We're going to hold off on number 2 because we need to find the volume of a cylinder to be able to solve that. We haven't talked about that yet. We're also going to need to find volumes of prisms, just like we found surface areas of prisms. So there are a couple prisms that we have on our formula sheet. This one here with the triangle will work with any base, and this one here is going to work on anything that is a rectangular prism. So that means one of its faces is a rectangle. So the formulas are the volume of the base times the height. So volume is equal to BH, or volume is equal to length times width times height. So we're already given H is height, L is length, W is width. This one only works on rectangular prisms. So if I take a look at number 1, I see that is a rectangular prism. In order to do number 1, I'm going to use this formula right here. I'm looking for volume. So the volume is going to be equal to length times width times height. So I can call the length 8 inches, the width 15 inches, and the height 10 inches. So whenever I do that, it's just going to be 10 times 15 times 8. And I see that's 1,200. And my units are going to be inches cubed. So remember, with areas we have inches squared, or we have any units squared. With volume we have units cubed. In order to solve for number 2, moving on to that, we need to use our other formula for volume, which is base times height. So the area of the base times the area, times the height. So we have volume is equal to BH. First, we need to find out the volume of the face, or the base. So the area of a triangle, I guess I should call this capital B, the area of the base, is going to be 1/2 lowercase b times h. Here it is right here. That's something that you should remember from earlier on. So I'm given the base and the height, so it's 1/2 times 3 times 4 which is just 6 meters squared. So that's an area that's going to have units squared, and the height is just going to be 6 meters. So the volume is going to be 6 times 6. So I got this 6 here. That's the base, the area of the base, and the height is 6. So whenever I multiply them, the volume is going to be 36 meters cubed. Another thing we're going to need to know to find the volume of is a volume of a cylinder. So again, we look at our formula sheet. Let me erase everything that we did in the prior two examples. For a cylinder, that's this right here. The volume is going to be pi r squared h. So the volume is going to be equal to pi r squared h. So the height is h and the radius is r. Let's do number 2 because that's more complicated. Number 2 says, what is the volume of the empty space? So remember, we're looking for, whenever we look at word problems, we're looking for which, what, where, some question we want to solve what we're trying to find. So our game plan here is the volume is going to be the volume of the cylinder minus the volume of the sphere. Because if you think about it, the empty space is wherever the sphere is not. So we're just going to use our formulas. So we have a radius, that's going to be 5 inches, and we have a height, which is going to be 10 inches. The height of this cylinder is 5 plus 5, which is 10. So I just use the two formulas that I have. I have pi r squared h minus the volume of a sphere, 4/3 pi r cubed. And then I just substitute what I have into it. So I know that the radius is 5 squared. So in order to solve this, I'm just going to punch everything in. I'm going to type it in exactly as I have it. Well, I guess the one thing I'm going to have is the fraction 4/3. I'm going to put that in parentheses to get rid of some confusion. So whenever I hit enter, I see that's 261, about 261.8. That's going to be inches cubed. So that's all we have to do, is just two problems, substituting. Once you have the setup, it's just plugging things in. So moving on to our second page, we have the volume of a pyramid. So we have 1/3 base times height. We see that the pyramid is in the lower right-hand corner of our formulas, and that's what we have. So B is the area of the base, and H is just the height of the pyramid. So let's do number 2 together, because number 2 is a little bit more complicated. Actually, number 1 might be, because we're not given the height for number 1. You need to find that. So again, I mentioned this on the last video with surface area and volume. You have to be careful that you distinguish the difference between the height and the length. So for volume, we need height. For surface area, we needed length. So in order to solve number 2, we're given the height. So the volume of this figure is going to be the volume of the pyramid plus the volume of the cube. So if I use my formulas, I need to find the base, the area of the base. It's just going to be 8 times 8, which is 64. So I should realize that the base is just a square or a rectangle. So either I multiply by length times width or I square one of the sides. The height is 8, and I also have a length equal to width equal to height. Those are all 8. So whenever I find the equation, it's going to be 1/3 base times height plus length times width times height. I'll allow you to finish that problem off. Let's go back to number 1 though, because one of the trickier things that you have to do is find the height here. What you need to do in order to find the height, so I have this one here, is you need to see that this length right here is 3. That's because this whole thing is 6 and half of it is 3. So I have a triangle here with 3, the height, and 5. You use the Pythagorean theorem, so 3 squared plus h squared is equal to 5 squared. H will be equal to 4. And once you have h is 4, you're just going to use 1/3 base times the height. So if you have any questions on that, hopefully that made sense. I know we did a couple examples like that with surface area where we were finding the hypotenuse. Again, the Pythagorean theorem is very important. So we're going to skip number 3 and we're going to go to a volume of a cone. The formula for a volume of a cone is right here. It's 1/3 pi r squared h, where r, of course, is the radius and h is the height. So this paper says to find the surface area of each solid. Let's change that to mean volume, because we already talked about how to find the surface area in the last video. So let's do 1 and 2 together. We're just going to use our formula, 1/3 pi r squared h. So we know the radius is going to be 8 yards, and the height is also going to be 8 yards. So all we do is just plug it in. So because I'm crunched for space, I'm not going to write it down, but I'm going to solve it on the calculator. So I just punch everything in. So it's going to be 512 over 3 pi. That's going to be its exact value, or its approximate value is going to be 536.1. So I guess I do have a little bit of room to write it, which is approximately 536. Of course, it's yards cubed. So in order to solve number 2, we need to find the height. We don't have the height. We have the radius. So remember, the volume is equal to 1/3 pi r squared h. And right away, I know that the radius is 3 feet. I need to do a little bit of work to find the height. Again, I'm going to be using the Pythagorean theorem. I have 3 as the bottom of a right triangle, or the base, and 19 as, 19 is the hypotenuse. So that means 3 squared plus h squared is going to be equal to 19 squared. So h is going to be equal to the square root of 352, which is about 18.8. So h is about 18.8 feet. So we'll put the square root of 352 in here, because that's its exact value. 18.8 is just an approximation. So whenever I have the radius and the height, I just plug it in. So remember, whenever we put the 1/3 in, to put that in parentheses. So 1/3 pi times 3 squared times 18.8. Actually, what I'll do is I'll hit second answer, because that way I'll get the exact value. And that'll get me a more accurate answer. So it's about 176.8. feet cubed. So I hope that was helpful. There's a couple problems here that we didn't do. It'd be a good idea for you to practice those on your own. Hopefully this made more sense. I think the volume's a little bit easier than surface area, but we'll come in, we'll have a little bit of practice, and I hope this video is helpful. Have a great day.